In this last module, we will be talking about soils and ecosystems. And the reason why we do ecosystems and soil material at the end of the course is because they really help us to integrate a lot of information from throughout the course. We talked all about atmosphere and climate issues in the first part of the course, and then we talked about landforms. When you put these things together, you really can understand better how soils are created. In addition to this, soils are just super important. They feed us. They dictate what sort of agriculture can take place where, and they are tied to our food security, especially since they're under threat by greater and greater degradation by humans. Populations are growing in most parts of the world, and climate is changing and sometimes challenging the way that soils are being formed. So we won't talk a great deal about that here, but it's important to keep in the back of your mind that soils are important not only because they help us understand physical geography as a whole, but because they are inherently important to humanity. Soils are formed from various processes that cause the parent material to break down and have new chemical material added to it. That parent material is the rocks that we talked about before earlier in the course, or the sediments that are collected in an area for one reason or another. Climate acts on these, and as climate acts on them, the soil starts to break down. It starts to weather chemically and physically and becomes smaller and smaller components. Eventually, plants begin to grow in the soil and start to add new materials to create the soil. Unless, of course, it's an extremely steep area where the soil may always be creeping downhill. Over time, over long periods of time, we eventually get the formation of soil. When we think about soil, we actually think not only just about sort of dirt, but the fact that soil is quite complicated in its nature. It actually has what's called a horizontal nature to it, or horizon. That includes organic material near the surface of the ground, but as you go deeper and deeper into the soil until you eventually reach that parent material, you often have layers in the soil that are extremely important to soil scientists. I'll talk a little bit about those layers, but you should just know that that's an important part of soil science, as is the chemistry of the soil that can dramatically change depending on climate conditions or the parent material. Chemistry plays a really big role in what can grow and how things can grow. In addition, colloidal material, which are small particles that are suspended in the soil, are also very important to what can grow. And we'll talk a little bit about that as well as we proceed. There's a lot more. In fact, we could dedicate a whole course to soils, but obviously we just have a few minutes to do the introductory material. In this class, we are going to talk about a basic dozen or so soil classes and the regimes, which are specific soil processes that form them. You'll probably want to go back and forth to this map that you can find in the text to look at these soil classes and then think as well about the regimes. The first one we'll talk about will be the tropical soils, or the classic tropical soils, which are called oxisols. Oxisols are dominated by a soil regime that's called laterization. And in laterization, what happens essentially is conditions are very warm and very moist, so things that die decompose very quickly. And because there's so much moisture in these areas, that organic material gets washed away very quickly. One would think that tropical rainforests would have a lot of organic material, but actually they don't because of that laterization process. The soils themselves end up not being particularly rich because of this and because of large soil moisture surpluses that take place in them. A lot of material gets washed away ultimately into streams, into the water table, and what you're left with will be relatively heavy insoluble material, like mineral material. In fact, there's a specific kind of oxisol called laterites, which are essentially like blocks of metal almost. This is one of the reasons why traditionally swidden or slash and burn agriculture is used in tropical areas, because there isn't a lot of good soil material. So you have to cut everything down and burn it before you can release good nutrients into the soil. The soils are often very red or weathered, rusty, literally, because of the poor soil conditions. In very dry areas, just the opposite, we have another regime called salinization, which is just as it sounds, the salting of the soil naturally. Water, as we know, precipitation, has a lot of soluble salts in it from precipitation nuclei. When that falls on the ground and is relatively quickly evaporated away, it leaves behind salty residue in the soil. That's not good for agriculture. Salt is bad. It changes the chemical nature of the colloidal material and makes it very difficult for nutrients to be transferred to plant roots. That's the bad news. The good news is, though, that a lot of the non-soluble material, the stuff that can be used really well for agriculture, is there. You just have to get rid of the salt, which is pretty soluble. So fields that can be, or soils that can be adequately irrigated are often very good agriculturally. But you can definitely over-irrigate too much and cause that soil to sort of move upwards in the soil. The mollisols are the best soils in the world. They are dominated by calcification. Calcification takes place essentially when all the good material is brought up through relatively large soil moisture deficits in the summer. So instead of getting itself washed away, it gets trapped. Now, it can be trapped too much. You can have so much of this material pushed down through the zone of alluviation into the zone of illuviation that it ultimately creates sort of like a crusty, calcified layer, which is bad. But for the most part, the mollisols are good. And this is where the bread baskets of the world are, the big grain growing areas, as you can see on this map actually. This is a little diagram that shows that process of calcification and a wheat field. The mollisols are often paired with the alphasols and eutasols that are found in the same parts of the world. The alphasols are only moderately alluviated, which means that they're not as weathered, and so they're good places for agriculture as well. Many parts of the lower 48 that are mollisols that are very big agriculturally productive areas are alphasol areas. The eutasols, which are shown in the lower right-hand part of this map, have more lateralization and more weathering, but also some degree of calcification because they have some summer deficits that helps to sort of off-balance that. These areas tend to have more weathered soils. They are not as good agriculturally, but can be very agriculturally productive with enough nutrients being added. You can see many parts of Southeast Asia that have extremely intensive rice cultivation in them are eutasolic in nature, but very good job of capturing water and irrigating. Changes the equation so that those soils are relatively good. The spodosols are one of the northern soils. They are found in areas where there's a lot of podzolization. Podzolization takes place when you have cool, moist climates and things don't decompose very well, sort of the opposite of lateralization. But ironically, the same processes happen in podzolization to some extent as happen in lateralization. In lateralization, everything gets washed away. It leads to a fairly acidic soil. In podzolization, everything stays, and you end up getting a lot of extra moisture that is essentially steeping in decomposing organic material, which becomes relatively acidic in nature and causes acidification of the soil. Oftentimes you get this sort of grayish quality to soils in these sorts of areas. That's a process known as glyzation. So podzolization and glyzation often work together in these spodosolic areas. Pretty limited in terms of agriculture, but there is agriculture in these areas. Another cool type climate are the histosols. These are places where organic material decomposes so slowly that it often forms peat like material, peat bogs, for example. Anaerobic decomposition means that material gets trapped in the soil for very long periods of time and eventually becomes a new material. Glycation is pretty common, especially below the level of the histosols in these particular areas. So think bogs in this sort of an area. And the gelisols are the most northern of the climates. They are often found where you have cold and frozen soils that leads to a lot of that frost churning or cryoturbation, which we talked a little bit about already when we talked about permafrost landforms and the pattern ground and all that sort of thing. But it also has the impact of pushing organic material downwards, bringing rocky material up to the surface rather, and it leads to the same sorts of problems of too much acid, a lot of extra clay-like material down low, and that glaciation that I have already mentioned. Take a look at a map and find where most of these major soil types are and think about those particular soil formation processes. Now, in addition to the major soils I just mentioned, there's some other soils that are definitely worth talking about, including both entosols and inceptisols, which are very young soils. So these are soils that are found in places where you have a lot of active erosion or a lot of stuff being deposited, or in places where you are constantly getting new material added onto it, even if the material is relatively good, like you find in alluvial plains. A lot of the soils that are found in south central Alaska are in fact entosolic or inceptisolic, depending on their age and maturity, because this is also a product of soils that have been created through glacial formation processes, relatively young, new material that's been left behind that hasn't had the opportunity to develop properly into a soil yet. The andesols are volcanic soils. They tend to be very young soils as well, but can be very rich soils for agriculture. Some of the wet, dry climates of the world have a type of soil called vertisols. I'm not going to spend any time really talking about those, but you should just know that that is another type of climate, or soil rather, excuse me. All right.